Welcome to Brain Vision.
Hi. So on our question today, I want to find the instantaneous velocity and instantaneous acceleration given the angular velocity and angular acceleration. So first of all, we need to find the radius from this diagram. But given that this distance is 300 and this distance is 500, and so we can find this distance by using cosine because we know this angle. This side is the adjacent side, this side is the hypotenuse. So cos 60 is equal to, let's call that side y, over the hypotenuse, which is 500, and cos 60 is 0.5, so 0.5 is equal to y over 500, and our answer is y is equal to 0.5 to 500 is 250 millimeters. So the radius from point O to the end at point, when you trace down point B, is going to be, we add the two, we add OA and the distance we just found. So our radius is going to be 300 plus 250, which is equal to 550. And to convert that to meters, we divide by 1000, so that is 0.55 meters. Next, we can just plug it into the formula for the velocity, and we get our velocity. So A V is equal to R omega, and V is equal to the radius 0.55 times omega 20, and that's equal to 11 meters per second. We need to take our direction into account. So we've been told that the angular acceleration is directed here. You can see it's right here. So the angular acceleration is directed counterclockwise. So that means the tangential acceleration at point B is going to be facing this direction. And that's negative x, because this is the positive x. As we can see in the diagram, it's all indicated there. So we're going to have minus 11. And since it's in the x direction, it's going to be I. And then for B, for the acceleration, this is in two parts. We're going to find the tangential and then the normal acceleration, and then we'll find the resultant of the two to find the acceleration. So let's start with the tangential. AT is equal to R alpha. So the radius is 0.5, sorry, AT is equal to 0.55 times alpha is 40, and that's equal to, give me a second, 22 meters per second squared. Also direction, we can see that the acceleration is directed this way, angular acceleration is directed this way, so that means the acceleration at point B is going to be like this, tangential acceleration, and that is the positive x, so plus I. And then finally for the normal acceleration, A n is v squared over r, which is essentially the centripetal acceleration. So we're going to use this velocity. That's minus 11. Minus 11 over r. The radius is 0.55. So that's squared. And this is 121 over 0.55, which is equal to 220. 220 meters per second squared. And also, we're taking direction into account. So the centripetal acceleration, which is the normal acceleration, is going to be directed right here towards the center. So this is actually the negative y direction, and this is the positive y direction. So our, we are in the we are in the negative y direction. So this is going to be negative 220, and since this is y, this is going to be j, excuse me, j. So to find the acceleration, finally, we need to find the resultant, which is gotten by simply adding the two vectors. So we're going to have 22i plus minus 220j, and that is in meters per second squared. And that is our answer. So A, velocity is minus 11i meters per second. And B, the acceleration is 22i minus 220j meters per second squared. There you have it.